Hello and welcome. Thank you for joining me again in this project review. Today, I have an exciting project to walk you through. I have deployed an 8 billion parameter AI model, DeepSeek, on AWS using Terraform infrastructure as a code and GitHub Actions for CI/CD automation. But why will anybody want to do this, and why is this project useful? It is useful in an instance if you are heavily dependent on an AI model to run your applications. If you're heavily dependent, then relying on an external API sometimes can be very expensive. And of course, if you need performance optimization or customization, then you also want to run a private AI model. Also, if you have to deal with data privacy and compliance or security, then this is also an use case for you to deploy a private AI model. So if you're interested in cloud computing, infrastructure automation, and DevOps generally, then I hope this project will be useful to you. In that case, let's dive in. First, I start with the high-level overview of the architecture diagram. So the architecture diagram is simply explaining and listing the services that have come together for this project to run. And of course, it's also telling us how the services interrelate for the project to be successful. Now, I will start with my major component, which is my EC2, Elastic Compute Cloud. This is the core service or infrastructure that serves the application, the model, AI model to users. Now, this EC2 is running in the private subnet, meaning that it has no internet connection natively. What I've done is why did I move it to my private subnet? Because this project is an update. The first version, the EC2 is running in the public subnet, meaning it is accessible over the internet. One can SSH into it, even though I have limited that access to only my own IP address. No one can access it. However, for safety purposes, for security purposes, and easy management, I have moved my EC2 to the private subnet, and there comes a problem of how I'm going to access the internet via this EC2. Because this EC2 natively won't be serving the model will be running in a Docker container, which I'm going to install on the EC2, meaning the EC2 still needs an internet access for me to be able to download and install the Docker application. Now, and that is where the issue of NAT Gateway comes in. Yes, NAT Gateway is missing from this architecture diagram. I'm going to create it immediately I finish explaining this architecture diagram. So via my NAT Gateway, my EC2 can have access to the internet. It can make an outbound request to the internet, which will be granted, but an inbound request won't come in. Okay, so but how do I manage my EC2? How do I run commands? That is where my ASM comes in, my AWS Systems Manager. The Systems Manager can run command against the EC2, and how to access it will be through a VPC endpoint. So the VPC endpoint helps Amazon resources to talk together privately using their private IP addresses. Okay. And for that to be possible as well, my EC2 will need a role that will have the appropriate policy for SSM to be able to access it. And my IAM is already there. And of course, my AWS Certificate Manager manage my TLS connection, my certificates, yes. And I've used my application load balancer. The application load balancer simply distributes traffic to the EC2 if there are more than one. And my AWS firewall, which is also a major update to the first version. It wasn't there in the first version. This blocks malicious IP addresses because I've added the appropriate rules for this project, or for my backend, for my WAF, to block inappropriate IP addresses, bad IP addresses, SQLi injections, cross-site scripting, and different types of attacks. My WAF can block them, and bots. If the WAF notice these are bot requests, it should be able to, and it can block those requests. And then my Terraform assesses the state of the infrastructure in an S3. So how does this work? If a developer pushes updates to main, if I push an update to my Git main branch, it kickstarts the workflow in that branch, and then this tells Terraform to create the infrastructure. So Terraform is going to create all this infrastructure. Okay, so before it creates the infrastructure, Terraform checks the S3 bucket to see the state file and say the current state of the infrastructure. If this infrastructure are non-existent, Terraform will go ahead to provision them, because I'm going to share the Terraform code in a bit. Okay, so it creates all the infrastructure, but if it checks the state file and see that they all have their record in the state file, it's not going to create any infrastructure. And of course, if I'm just making an update, Terraform will just update only the new resource that I'm creating. And then I can also destroy the infrastructure by running a command, by pushing to main, or running a dispatch workflow event in my GitHub action. So before I go to the Terraform code, let me quickly create the NAT gateway that is needed for my EC to access the internet. So this is my AWS console. I create a NAT gateway. Sorry, that's not instance, not NAT instance. NAT instance is another option, but that's a NAT gateway is simpler and easier to use than, okay, sorry. I mean, on my Amazon, let me go to VPC. Go to the VPC console. I should have included this in the Terraform config, but since I already have an existing VPC, so I didn't deem it fit to include it in my Terraform configuration, but it can be. So create the NAT gateway. I call it DeepSeek NAT gateway. The NAT gateway is going to be in a public subnet because it needs to access the internet. So it's already public, and allocate an elastic IP address and just create that. So when that is done, I go to my private route, and this is my public route. This is the private route. I edit the private route. Remove this one because it's not working. So all IP addresses should make a request should be forwarded to the NAT gateway. Select the NAT gateway that I just created. This is it. I save my changes. All right. So now I can go back to my infrastructure. So this is the main.cf. Okay, I think I should check it out on the GitHub. It's clearer here. Yes. All right. So first is my AWS providers block and VPC configuration. So this is the provider block. I've hard coded my zone, US East 1, availability zone, and the security groups. So I have created 3 security groups, one for the EC2, one for application load balancer, and one for the VPC endpoints. So for the EC2, it allows traffic on port 8080, and this is where the Open Web UI is running on. With the Open Web UI is where we are going to access the DeepSeek model on the web, which I'm going to show in a bit. And it also allows ingress on port 111434. This is Olama application. The Olama application is simply the one that opens the DeepSeek port API. It gives us access to DeepSeek via an API, and then it allows all outbound traffic. And this is the security group of the application load balancer, port 443, accessible on web from anywhere, and all outbound traffic is also accepted. And then this is the security group for the VPC endpoints, SSH 22 and 443. So for the load balancer, of course, listens on 443. It has a listener 443, and it has a target group. The target group is what the EC2 is attached to. It's listening on port 8080. And this is the IAM group for the VPC endpoint. The IAM group for VPC endpoints. And then every other VPC configurations are here. And this is where I have customized my domain. I have a domain existing already, which is firstdigitals.com. So it's a subdomain I've added to it. So my applications can be accessed over a custom domain. And this is my firewall configuration, AWS firewall. So first, I have limited access to 150. You can't make more than 150 calls in 5 minutes to my application. This is the limiting rule. And the other managed rules by AWS that I have also added. And of course, my state management. Terraform manages my state by storing the state file in Amazon S3. And these are my variable configurations and then outputs. All right. Next, it's my GitHub Actions workflow. So the GitHub Action workflow gives me flexibility to deploy my infrastructure. If I push my infrastructure to main, it's going to deploy. I can also do a workflow dispatch by selecting apply on the GitHub Actions, on the GitHub Actions UI console. And I can also destroy my infrastructure project by selecting destroy, and that is going to run as well. Okay, so here comes the main stuff where I would pull a Docker container, pull an image, and run a Docker container inside the EC2. So after Terraform accesses or creates the infrastructure, the post-apply job is where the whole actions happen. Okay, so for the post-apply jobs, first, after the whole creation, the GitHub Actions actually verify SSM connection. So these are AWS SSM connection commands that I actually checked from the documentation, which I may link in the description section. And the SSM agent is also installed. I install Docker via SSM and all that, and then I run the DeepSeek model via Olama. Olama that is going to, this is Olama, will be opening the ports for us, and then the Open Web UI, this Open Web UI, which would give us access to access the infrastructure on the web, and then this is the destroy job. So let me quickly go back my main.tf and deploy the applications. Let's see. So I'm just going to make a little change to my workflow. So my workflow, okay, yes. So I can, on this, let me just add something, another job. Let me add an environment. Yeah. Okay, so I can deploy this now. Test deployments. Test deployments. Okay, so that is already going through. Go back to my actions and see. All right, so my deployment is already processing, and this is going to take maybe like 3 to 5 minutes, but I'm going to just put a pause here to ensure that, and I'll come back when it is done. It's running already. Terraform is still creating the infrastructure, and it will take a bit of a time. Okay, so that took like 5 minutes to run. Now my workflow is successful. Now I can go back and check. First, let me go to my AWS console and see the VPC that's been created, the EC2 that's been created, and see if it actually has internet connection. Okay, the instance has been created. Let's see. All right, so public IP address, null. There's no public IP address, so it's created in its private subnet. It has a private IP address, okay? And if I go to networking and just see, so the subnet ID, you can see that it's a private subnet. So this instance has been created in the private subnet, which is actually valid, but let me attempt to connect to it. I can't connect via SSH because it doesn't have, if I try to connect, this is going to fail brutally because it is created in a private subnet. But let me try. We are going to use Session Manager to connect and see, because SSH agent is natively installed in the AMI that I've used, the Ubuntu AMI that I've used. So we should be able to connect to the instance and manage it through AWS Systems Manager. And now System Manager is running, and automatically we are inside the instance. Who am I? SSM user. All right, so let me just ping. This is Google's public DNS. Okay, it's running, so we can ping our Google, or we can just say ping the same thing that I just ran at the top. So it has public internet access. Oh, sorry, it has internet access via the NAT Gateway. So I'm just going to see if my Docker containers are running. Okay, one of the Docker containers is running, just Ulama. I can't find the open web open web UI container yet. So I'm just going to wait a few seconds and try again. While like that, I can try again. Oh, sudo. All right, so my open web Docker container is running. So I can also check Docker logs. Open web UI. I think it's open. Yes, open web UI. All right, so it's running successfully. So let me just go back. Since everything is okay, I can go and access our EC2 over via the public domain that we actually gave it from the Terraform configuration. DeepSeek, yes. Oh, yeah. All right, so Shining website is actually running. Interface to actually access the model is running. Chat new frontiers wherever you are. So get started. Let's see. Put my name and just put any password. Of of course, for test purposes. Don't save. Oh no, what's new in the Open Web UI? So the Open Web UI gives us access model shining web interface. All right, so our DeepSeek model is actually running 8 billion parameters. So the first question I would like to ask, hi. Yes. So it can actually thinking. Our response is going to take a while, but depending on the compute power we have, we can get a faster response because we're just using the 8 billion parameter model, and I don't have access to GPU support for now because AWS did not approve the GPU support instance that I requested at the point of making this video. So it's actually responding and thinking, so which is a good one. Working properly. Let me just leave it for the response to be complete. So that's well answered. Just try one more. Model is thinking about the question. Let me pause for a brief moment. So it took 2 minutes for it to think and it has responded. All right, so the model is working properly and everything is fine. So if you just want to check the Open Web UI page that I'm using to deploy this project, this is it. Open Web UI. Okay, this is their documentation. Okay, so but you'll find everything here you need to do is they will provide you, if you want to use GPU support, there are instructions on how to do that. And if you want to run Olama, because this project can actually be done locally, if you want to run it locally on your computer instead of doing it on cloud, it is also very possible. This is where you download the models, and here are all the models on Olama. The Olama provides exposes the model through an API. So for the DeepSeek model, this is the one I'm running, 8 billion parameters. So 14 billion parameters, 671 billion. Of course, this is the type of ChatGPT, and also the lower you go, the lower the number of parameters, the dumber the model. So of course, 14 billion parameters should be smarter than 8 billion, and 32 billion should be smarter than this. But of course, you need bigger machines with memory and compute power to run all these machines. So codes, the configuration files, you can check it up on my GitHub page. Everything is there for you to access and replicate if you want to do that. Thank you for joining all the way. This project demonstrates the power of infrastructure as a code and CI/CD automation in deploying an AI model in the cloud. If you found this useful, please like and let me know what you think in the comment section. Then I also like you to subscribe for subsequent videos in the cloud DevOps domain. Thank you and see you in the next video.